In this video, we're going to look at the hyperbola, which is the last of our conics. So the hyperbola it's a graph that sort of looks like two parabolas facing away from each other. So you can either have a hyperbola with a horizontal orientation, where your two branches are facing left and right, or you can have a hyperbola with a vertical orientation where your two branches are facing up and down. So to start with, let's take a look at this example of hyperbola with a horizontal orientation. So you can see that our two branches here are opening to the left and to the right. So because of that, we have what's called the transverse axis that passes right through the middle and intersects the two different branches of our hyperbola. Now, those points where that transverse axis intersects the hyperbola itself, those are called the vertices. Okay, and then right in the middle of that is the center, okay? Now you'll also see we have the second axis of symmetry that goes right down the middle between the two branches of our graph, and that's going to be perpendicular to the transverse axis, and that's what we call the conjugate axis, okay? A couple other things that I want to point out on here. You'll notice that we have two foci, right? And those are always going to be on the transverse axis, sort of sitting inside the curve of your hyperbola. So if your branches of your hyperbola are opening left and right, then your foci are going to be to the left of the leftmost branch and to the right of the rightmost branch. Now, one other thing that's a little different about these hyperbolas compared to the other conics that we've looked at is that we have two slant asymptotes that are going to help us to sort of figure out how wide the opening of our graph is. So you may remember that with our parabolas, we had those 2 points on the latus rectum. That was the way we figured out how wide the opening of our parabola was. Well, with the hyperbolas, we're going to find these asymptotes instead. And always remember, just with an asymptote, your function is going to approach that line, but it's never actually going to reach it. Okay, so let's go ahead and let's take a look at the equations of our hyperbola. So there's two different equations for a hyperbola, depending on whether your hyperbola is opening left or right, or whether it's opening up or down. Now, if you look at our equations over here, you'll notice that pretty much they're very similar to the equations that we had for ellipses. The main difference is instead of having a plus in the middle, we're going to have a minus in the middle. So with that subtraction, that's how we know that it's going to be a hyperbola, okay? So because of the subtraction, that means that the order of these two terms right here is important because which one is positive and which one is negative is going to make a difference on what your graph looks like. So if the x squared term is first, if the x squared is the positive term, then your transverse axis is going to be horizontal. But if the y squared term is first, so in other words, if your y squared term is the positive term, then your transverse axis is going to be vertical, okay? Just like we've seen before, h and k tell us the center of the hyperbola. The a value on these is going to tell us the distance from the center to the vertices, okay? If you use this equation up at the top, the b squared is equal to c squared minus a squared. The c value tells us the distance from the center to the foci. Now the b value with hyperbolas only serves to help us figure out the slope of the asymptote. So notice if you look at the equations of our asymptotes right here, they have that same y minus k and x minus h that we see in our original equation. So you're literally just going to copy and paste that factor over. And then the slope is always the ratio of a and b. So for the horizontal transverse axis, your slope is b divided by a. For the vertical transverse axis, your slope is a divided by b, okay? And it's always just a plus and a minus because you have two asymptotes. The best way that I can help you remember whether it's b over a or a over b is just remember that slope is always rise over run. So slope is y divided by x. So if we focus on these numbers that are underneath our x squared and our y squared terms, for the horizontal transverse axis, if we're thinking y divided by x, we would have b divided by a as our slope. And then in the case where our transverse axis is vertical, y divided by x is a divided by b for the slope, okay? Okay, so these are the equations of our hyperbolas. So let's go ahead and take a look at an example, okay? All right, so we want to start by graphing the equation of the hyperbola. Now, that means that we're going to have to figure out the orientation. We want to find the center, the vertices, the asymptotes, and the foci. Now, the first thing that I notice here is that this equation, 2x squared minus y squared, is set equal to 4. But if you look back up at the equations of our hyperbolas, we always want them set equal to 1. So if you have anything other than a 1 on the right-hand side to start with, go ahead and just divide everything through by that number. So in this case, I'm going to go ahead and divide everything through by 4. Okay. All right, so that's going to give me x squared divided by 2 minus y squared divided by 4 is equal to 1. Okay. All right. Now, one thing that I'm not sure I mentioned up here is that with hyperbolas, it does not matter whether the a or the b term is larger. The a is always just going to go with the first term, and the b is always going to go with the second term. So with ellipses, we saw that a is always the bigger number. That's not necessarily the case with hyperbolas. A could be the bigger number, a could be the smaller number. It doesn't matter. The only thing that matters is that a goes with that first term, okay? All right, so in this case, that means then that our a is equal to the square root of 2, and our b is equal to the square root of 4, which is just 2, okay? All right, so now for the orientation of this, because our x squared term comes first in our equation, that means our transverse axis is horizontal. All right, and because there isn't really an h and k to speak of on this one, it's just a plain x squared and y squared, our center is right at the origin at 0, 0, okay? All right, let me go ahead and start plotting some of this. So we have our center at 0, 0, and our transverse axis is horizontal, which means our conjugate axis is vertical. Okay. Okay, so this is our transverse axis, the horizontal line that passes through the center, and the conjugate axis is the vertical line that passes through the center. All right, then using our a value, so a is equal to the square root of 2, or since we're graphing, it might be helpful to find that as a decimal. So that's approximately 1.4. We can find our vertices. Okay, so to the left and to the right of the center, because our transverse axis is horizontal, we're going to count 1.4 units out in either direction and plot our vertices. Okay, so 1.4 units out in either direction would give us negative 1.40 and positive 1.40. So those are going to be our two vertices. Okay, those are our vertices. All right, then using the A and the B value, so with an A of 1.4 and a B of 2, we can find the asymptotes. Okay, so remember for these, it's always going to be y minus k is equal to plus or minus b divided by a times the quantity x minus h. Okay, so for our example, y minus k is just y. It's equal to plus or minus, okay, and we're using b divided by a on this one because b is under y and a is under x, so plus or minus 2 divided by 1.4 times x, okay? Or if you want to simplify that a little bit, our y would be equal to plus or minus 2 divided by 1.4 is 1.4. So y is equal to plus or minus 1.4x. Okay, so these are the equations of our slant asymptotes. So remember, your slope is giving you your rise over run. So basically from the center, I'll do the positive first. So I'm going to go up 1.4, right 1, and then I can go ahead and just connect that with a straight line. And I got my first asymptote. Okay, and then the negative, so from my center, it's going to go down 1.4 and right 1. And again, just connect those with a straight line. And we'll have our other asymptote as well. Well, those aren't perfect for sure, but you get the idea. Okay, so the last thing we need to find then are the foci, and that's going to come from our c value. So with hyperbolas, we can use the equation b squared is equal to c squared minus a squared. So b squared is equal to c squared minus a squared. So we'll have 4 is equal to c squared minus 2, which is going to give us c is equal to the square root of 6. And if you plug that in, that's approximately 2.4. And the c value gives us the location of the foci. All right, so from the center, we're going to count 2.4 units out to the left and to the right along that transverse axis to find our foci. So 2.4 units left is going to put us at negative 2.40. 2.4 units right is going to put us at positive 2.40. Okay. All right, so then just to graph our function then, we are going to have the two branches of the hyperbola passing through the vertex and then just approaching your slant asymptotes as you go out toward the edges of your graph. So just kind of a rough sketch to get that general idea. We are going to get something that looks like this. Okay, something roughly like that for our hyperbola. Okay. All right, guys, so I'm going to go ahead and end this video here. We'll probably do one more video looking at a couple more examples with our hyperbolas.